Welcome back to Computer Lessons.
In our previous video, we built the body of the computer. We talked about the CPU, the RAM, and the storage. The raw muscle and silicon that makes computing possible. But if you were to assemble all those expensive parts right now and press the power button, do you know what would happen? Absolutely nothing. Well, maybe a fan would spin, but you wouldn't be browsing the internet or playing games. Why? Because hardware, no matter how powerful, is inherently stupid. It doesn't know how to talk to the screen, it doesn't know how to store a file, and it certainly doesn't know what a mouse click is. It needs a manager, it needs a translator, it needs an operating system. Today we are going deeper. We are going to explore the invisible software that controls every single electron in your machine. Let's start at the very beginning, the moment you press the power button. This process is called booting, a term that comes from the phrase pulling yourself up by your bootstraps. Before Windows or macOS even appears, a tiny piece of software stored on your motherboard wakes up first. This is the BIOS or UEFI. Its job is to perform a roll call, known as the power on self-test. It checks, is the RAM there? Is the processor working? Is there a hard drive connected? If everything is okay, the BIOS looks for a special drive to hand over control to. It basically says, okay, hardware is ready. Operating system, you have the controls now. And that is when you see the Apple logo or the Windows loading circle. It's a passing of the torch from the hardware firmware to the software manager. So what exactly is an operating system? Is it just the desktop wallpaper and the start menu? No, those are just the clothes it wears. The real operating system lives deep underneath. This core component is called the kernel. Think of the kernel as the absolute dictator of the computer. It has complete control over everything. When you open a web browser, the browser cannot touch the RAM or the CPU directly. If it did, it might accidentally crash other programs or steal your data. Instead, the browser has to ask the kernel nicely. Dear kernel, may I please have 200 megabytes of memory? The kernel checks its resources, decides if it's safe, and then grants or denies the request. This protection is why when one app crashes today, it usually doesn't take down the entire computer with it. The kernel isolates it. Now here's a problem. There are thousands of different hardware manufacturers in the world. There are hundreds of different graphics cards, thousands of different printers, and millions of different Wi-Fi chips. How can one single operating system like Windows know how to talk to all of them? The answer is drivers. A device driver is a small piece of software that acts as a translator. Your operating system speaks English. Your new printer speaks, well, let's say printerish. They don't understand each other. When you install a driver, you are installing a translator who says to the OS, when you want to print a page, just tell me, and I will translate that command into the specific electrical signals this printer understands. Without drivers, your fancy 4K graphics card is just a paperweight. This is why keeping your drivers updated is so important for performance. Another massive job of the operating system is managing files. We take this for granted, yet you save a photo and it goes into a folder. But physically, on the hard drive, that photo is just a scattered soup of billions of bits. The OS uses something called a file system to organize this mess. Think of the file system as a massive library index card catalog. Whether it is NTFS on Windows, APFS on Mac, or ext4 on Linux, the job is the same: to remember exactly which sector on the hard drive belongs to which file. It keeps a map of where everything is. If this map gets corrupted, the data might still be there, but the computer has no idea how to find it. That represents the difference between a working computer and a corrupted drive. Today, the world is dominated by three main families of operating systems. First, there is Microsoft Windows. It dominates the market because it is designed to run on almost any hardware. It is the jack of all trades, perfect for gaming and office work. Then there is macOS from Apple. Unlike Windows, macOS is only designed to run on Apple's specific hardware. Because Apple controls both the hardware and the software. The experience is often smoother and more stable, but you have less freedom to change things. And finally, there is Linux. Linux is open source, meaning the code is free for anyone to see and change. It runs the internet, seriously. Almost all the servers, supercomputers, and even Android phones are based on Linux. It is powerful, customizable, and loved by programmers, but it has a steeper learning curve for beginners. So, the operating system is the ultimate manager. It boots up the hardware, manages the memory through the kernel, talks to devices using drivers, and organizes your data with a file system. It is the platform that allows us to be creative. Now that we understand the hardware and the operating system, we have built the stage. But before we write code, we need to learn the alphabet. In the next video, we will explore bits and bytes, the invisible DNA of zeros and ones that makes the digital world exist.
If you are ready to stop just using computers and start understanding them, make sure you are subscribed. Leave a comment below telling me which operating system you use and why. See you in the next lesson. If you found this explanation helpful, please hit the like button and subscribe to Computer Lessons. Don't forget to click the bell icon so you don't miss our next class. Thanks for watching and keep learning.